you already have obtained the links of the recordings that we have last time. So ito yung last time na magbibigay tayo ng lecture. Next time is more on clarifications doon sa course pack nyo. Okay? So we have discussed about acid. We says it's surface, react with metals to produce hydrogen, react with bicarbonates and carbonates to produce CO2. Bases, on the other hand, they have a bitter taste and a slippery feeling, like most of the soaps that we have. So last time we discussed about the Bronsted-Lowry definition of an acid, wherein we said an acid is a donor, a proton donor, or a hydrogen donor, while a Bronsted base is a proton acceptor. So in your question in the quiz or your what we call departmental exam, you might be asked which of the following here is an acid and which of the following here is a base. Okay, so how do we know which is the acid, which is the base? Usually you lose a hydrogen for you to become an acid, and if you're a base, you gain a hydrogen. So if you lose a hydrogen, in the end you will become the conjugate base. If you gain a hydrogen, you become the conjugate acid. So Bronsted-Lowry definitions of acid is base is mostly conjugate. Where did you hear the word conjugate? The root word is what? Conjugal. What does it mean if it's conjugal? Usually husband and wife. I think that's the one that they have. Okay? Now, the conjugate acid would always have one hydrogen more. And the conjugate base would always have one hydrogen less. So here, if you're asked to answer this question, so which is the acid-base pair here? Paano nyo sasagutin to? So this is the acid, and what do you call this F minus? Are you with me?
Conjugate base.
Conjugate base. And if this is the base, this is your what?
Conjugate acid.
Conjugate acid. Okay, because you might have question, what is the conjugate acid of H2O? What is the conjugate base of H2O? So ano yung conjugate acid ng H2O? Ano yung conjugate base ng H2O? Anyone?
Try lang po, sir. Yung conjugate acid po, H3O. Then yung conjugate base po ay HO.
So as I've told you, a conjugate acid is one more hydrogen, okay, or H plus, hindi lang hydrogen, H plus. And a conjugate base is one less hydrogen plus. Okay? Because yung proton, synonymous yan sa H plus. Okay. So we already discussed about the we could say amphiprotic or amphoteric property of water. It's discussed there in one of the material in your course pack. So water can undergo auto-ionization where one of the hydrogen from water goes to the other water, giving you a hydronium ion and a hydroxide. So they can act both as an acid or a base. So yun yung tinatawag na amphoteric or amphiprotic. They can act as an acid or a base. Okay? Now, that unique property that they have also give them this so-called Kw, which is just equals to the ionization of water to produce H plus and OH minus. Now, what is this Kw? This is the ion product of water or dissociation product of water. Dissociation constant of water. And it's just the product of the molar concentration of your H plus and OH minus. Now, whatever is the amount of your H plus with respect to hydroxide, your Kw will always be 1.0 times 10 to the negative 14 at 25 degrees Celsius. So whether pareho sila Yung isa lamang sa isa, ang product niya ay ito. But this is at 25 degrees Celsius. What do you think happened if the temperature increases? What happened to Kw? Anyone? Pwede mahula. So sa tingin niyo mangyayari kapag tumaas yung temperature sa Kw value? Anyone wanna guess? Tataas ba? Bababa? O pareho lang?
Bababa po, sir.
Bababa? Yung iba? Parang bababa ba? Sagot mo, bababa. Okay? When the temperature increases, usually the Kw also increases. So which tells you the reaction is what? Exo or endo? Kapag tumaas ang temp, tumaas ang Kw, ano ibig sabihin nun?
Endothermic po.
Okay? So it is an endothermic reaction. So, ano mangyayari sa H plus or OH minus? Tataas din sila. Hindi lang natin alam alin yung tataas. Because as I've told you, okay, kung ano man yung ratio nila sa isa't isa, the Kw is just the product of the two of those ions. And they can tell you whether you're acidic, basic, or what we call neutral. Now, the one that we need to know is how do we measure the H plus? How do we measure the hydronium ion concentration? So there's a way to do that. And usually, meron tayong tinatawag na demarcation line, which is a pH equals to 7. Na sinasabi natin, if it's more than 7, it's basic. If it's less than 7, it's acidic. If it's equal, it's neutral. But if you're going to look at this pH, it just tells you the relationship of the ions concentration with one another, especially H plus and hydroxide. Okay? And I think we started this before. So sinabi natin, as the pH increases, the hydronium concentration decreases. So ang relationship ng pH, if it's low, the hydronium concentration is high. So ito kasi yung mga concept questions na pwedeng lumabas eh. Especially now I know how they, what we call ask question. I'm not even sure if I'm going to ask question, but all I know is I'm going to what we call make sure na yung question na lalabas eh katulad sa inyo. Katulad ng mga inaano natin. Okay? So, how do we measure pH? Meron tayong pH meter. Okay? And this was developed from the food industry to determine the quality of beverages. And this is the idea of the pH value that you have. So, as I said before, lahat ng kinakain natin, acidic, okay, lahat ng panlinis, basic. Now, aside from pH, we can also apply that concept to a pOH. Okay, so let's say you have a base. So you cannot get the pH right away because the base doesn't have an H plus. What it has is the hydroxide ions. And we can relate the pH with respect to the base. Okay, we can relate the pOH also with respect to the Kw. Why? Because H plus times OH minus will give you the Kw, and its values, that's 1 times 10 to the negative 14 at 25 degrees Celsius. Now, if we get the negative log of all of them, so ano ibig sabihin nun? I-present mo ito, negative log nito, negative log nito, negative log nito. So this one becomes your what? That becomes your pH. This becomes your POH. And the negative log of 1 times 10 to the negative 14 will give you this one. Ito na yung relationship. Dalawa. So what we need to know? What you need to know is once you have the pH, you can express also its POH number. You can also express its H plus value and its hydroxide value. So from pH to POH, this is the one that you have. How about from pH going to H plus? What could be the formula that you can use? And the same thing that you can use for the hydroxide. So you can use 10 raised to the negative pH, 10 raised to the negative POH. Clear ba yun?
Sir, saan po nanggaling yung 10?
So remember, we have this one here, right? So what if this is the one that we want? Ano yung inverse ng log sa calculator nyo?
Antilog po.
And antilog is equals to what? Di ba 10 yun? Raised to whatever is the negative of the POH. Why is negative? Because negative to eh. It's a mathematical expression. Okay? So nagsimula dito sa, let's say, pH equals to the negative log of H plus. So what do we want? We want only this one. So how do we eliminate the negative log there? So we put 10 raised to the negative pH para maging H plus. Or 10 raised to the negative POH para maging OH minus. Okay? So kung hindi kaya, ito na lang alamin nyo. It's a math thing. Now, one of the objectives of this course pack, of this module in this course pack is for you to get the pH of strong acid, strong base, weak acid, weak base. That's why the first thing for you to know is how do we differentiate a strong acid from a weak acid and a strong base from a weak base? So we need to look at the concept. What is the strength all about? So when we're talking about the strength of the acids and bases, we're talking about the dissociation. If you are a strong acid or a strong base, you act like a strong electrolyte, wherein you undergo 100% dissociation. Okay? So what are these, what we call strong electrolyte? Like your soluble salts. When you put NaCl in water, if all of them dissolve, do you see a sodium chloride in the solution? Yes or no? Kapag na-dissolve ba lahat ng NaCl sa solution, makikita nyo pa yung sodium chloride? The answer is what?
No.
No, because they already dissociate to give you what? Na plus and Cl minus. So the same thing with strong acids and strong base. They undergo 100% dissociation. Now, compare it to the weak electrolyte like this one. So what does this mean? Less than 100%. Only certain amount dissociate. And that's the reason why you have a different arrow here. This is what? A one direction arrow, and this is a reversible arrow. So that means not all of these will dissociate to give you these ions. Now there's still one that is called the non-electrolyte. So what's the non-electrolyte? When you put it, it will not dissociate at all. But we're not going to discuss about that. Okay, because a strong acid and a strong base is one that undergoes 100% dissociation. A weak acid and a weak base is one that undergo to a certain extent some dissociation. Yun yung importante eh. How do you know it's a strong acid or a strong base? Well, it undergoes 100% dissociation. As simple as that. If it's a weak acid and a weak base, it dissociate to some extent. So what are the strong acids? So some of them are listed here. You know the technique here is you just know the strong acid and strong base, and if they're not in the list, they're weak. Klaro tayo doon? So there are 6, in some books 7. So there's 3 of them, what we call 4 of them already here. The other 2 would be HPR and HI. And in some book, they list HClO3 as a strong acid. Yes, question.
Hello po, sir.
Yep.
Indication po ba yung arrow po kung strong base po?
Yes, that's true. So kapag one direction lang, ibig sabihin, wala ka nito by the end of the reaction. Lahat ng strong acid mo in aqueous solution, ito na yung form niya. Okay? So the double direction arrow, the one direction arrow that indicates that you are a strong acid. So kapag strong acid ka, forward reaction lang, wala, complete dissolution. So wala nang backward. So yung strength ng conjugate base niya dito, mahina. Because it's just all in the forward reaction. Unlike this one, it can go forward and backward to some extent. But as we go on, you will see the difference between the two. So if you're a weak acid, so anything that's not listed here, that's weak. HF, okay, HN2, HSO4 minus, and water. Now, strong bases, all you need to know is the soluble hydroxides of group 1A and 2A. So, ano ba yun? Lithium, sodium, potassium, hydroxide, and then barium hydroxide, calcium hydroxide. Those are strong bases. And again, look at the arrow. Okay? Kapag one direction yung arrow, most likely it's strong. Okay? Now, weak, like this one. So you can identify here which is the acid between the two. So this is the acid, this is the base. So this is the conjugate base, and this is the conjugate acid. Baka may tanong kayong ganun eh. Okay? So the thing that you can remember in the conjugate acid base pair, the conjugate base of a strong acid has no measurable strength. So kapag one direction ka lang, yung conjugate base mo, wala. Mahina. And H3O plus is the strongest acid that can exist in aqueous solution. Kasi wala na yung mga strong acid mo, nag-dissociate na siya. Nag-form na siya sa H3O plus. At kung ano man yung conjugate base niya. The same thing with the strong base. When they dissociate, wala na yung initial identity ng species mo. Ang nangyari, hydroxide na yung nag-form. And to give you a photo of this one, try to look at this. If you have a strong acid, you see this one? by the time it reaches equilibrium, you don't have any HCl anymore. It's they dissociate to give you what? H plus and Cl minus. But if you have a weak acid, like the other one here, so you could see at the beginning it's all HF, but at equilibrium, you could see that you have some of them dissociating to form H plus and F minus. But the major species in the solution is still what? Ano yung major species ng weak acid? Yung weak acid pa rin. Kasi hindi lahat nag-dissociate. Only a small amount dissociate. Is that clear? Now, based on this, what we call concept, the next thing that we're going to do, so how are we going to determine the pH of a strong acid, strong base, weak acid, and weak base? Anong basis ng pH natin? Anyone? Ano yung kailangan natin malaman if we are asked for the pH? Hmm? Anyone? So pH is just equals to what? Negative log H plus. Now, the concept of a strong base and weak base is also the same as this. The only difference is what? Instead of the H plus, you have POH. So kapag base ang kukunin mo, you get the POH and then get the pH. Now look, if you have a strong acid, you can directly get the pH. All you need to do is determine the amount of H plus. And what you can say, pareho lang sila, di ba? Kung ano yung concentration ng HCl, kapag nag-dissociate ka, H plus and Cl minus. So kapag 1 molar dito, 1 molar din dito, 1 molar din dito. Now, the only difference, you only see this at the beginning. At the end, wala na yung 1 molar kasi nag-dissociate siya to give you 1 molar and 1 molar. But in the HF, what do you see? Kung may 1 molar ka dito, most likely, this is what? Less than 1 molar. And this is also less than 1 molar. So in the end, there is some amount of this doon sa amount na nag-dissociate. So we could say if you have a strong acid, strong base, you can get the pH and the POH. It's straightforward, but this one will take you additional step to do it. So let's try. So I want you to do this on your own. Mag-break lang ako. Kasi hindi ako nakapag-break last time. Give me 2 minutes, okay? So, paano gagawin natin dito? Anyone? So, ano yung HCl? Strong acid, strong base, weak acid, weak base.
Strong acid po.
So, strong acid. So, the best way we can do is maybe we can write the reaction, and then since a strong acid, one direction arrow, so you have H plus and Cl minus. Remember, we want to get the pH of this one. So it's the one that lag H plus. So all we need to do is what's the concentration of the H plus, and then we'll get the corresponding pH on it. So we have 0.0010 molar. So how much of H plus will be formed?
The same po sa HCl.
So we also have 0.001 molar. Have 0.001 molar. So we could just say negative log of 0.001 molar. And that is equals to what?
3 po.
3.00. Question on that? Sure ball ba pag ganito yung question?
Kaya naman po.
The next one, ano to? Strong acid, strong base, weak acid, weak base.
Strong base po.
Yan, nakasulat na dyan. So you can put the reaction here, and this will give you what? Ba2 plus 2OH minus. So you have here 0.020, 0.020, or we could just say initial, and then after nawala yung 0.020, nag-form ng 0.020 at nag-form ng 2 times 0.020. So in the end, wala to. So you form here 0.020 and you have here 0.040. Everyone buy this? Bakit nag 0.040 doon?
May 2 moles po dun sa OH.
Okay, so for every 1 mole of barium hydroxide, you form 2 moles of your hydroxide. And since this is hydroxide, we can start with the POH, negative log of the hydroxide. So you have negative log 0.040. So that is equals to what?
1.4 po.
So you could say 1.40. So significant figures, so you have 2 here. Sa pH, ang significant figures niya is after the decimal. So if you have what? 1, 2 here, so that means you have to write it 1.40. And since the one being asked is pH, so this is just equals to 14 minus 1.40, which gives you, oh God, 12.60. Analyze. Tanong kung medyo malabo. Tanong?
None po, sir, so far.
Okay. So, paano kapag weak acid? Are we going to use the same approach? Most likely hindi. Kasi nga, hindi naman siya 100% nag-dissociate. So, kung ano man yung concentration ng ng acid, hindi siya yung concentration ng H+. So, the way that we do it is we use equilibria. Okay? So, HA is, let's say, the general equation for, a general term for the weak acid. So, when we put it in water, it dissociates to give you H3O plus or A minus, or we can simplify it. Let's say HA dissociating to H plus and A minus. And we can write the law of mass action here. So we put here the Ka. So the Ka is what we call the acid ionization constant. So one clue for you, if you forgot the list of your strong acids, kapag given ng Ka value, ibig sabihin, weak acid yun. Okay? So, anong information ang makukuha natin sa Ka? So, usually, yung mga weak acid na yan, iba pa rin yung kanilang strength. Hindi ibig sabihin weak acid pare-pareho, lahat sila pareho lang yung strength. No. There are weak acid that's stronger than one another. So, let's say, yung acetic acid, maybe it's what? Less stronger than nitrous acid. We don't know. But the Ka value tells us that information. So kapag mataas yung Ka value, ibig sabihin mas marami yung na-dissociate ni acid, kaya mas stronger siya kaysa dun sa iba. Okay? So let's try to apply this concept kung naintindihan nyo. So between HF and nitrous acid, which is stronger? Which is the stronger weak acid between the two? Anyone? Alin yung stronger sa dalawang weak acid? Okay? So, ang basis po dyan Ka. So, 7.1 times 10 to the negative 4 is much higher or higher than 4.5 times 10 to the negative 4. So, that means HF is stronger than nitrous acid. Now, ano naman ang epekto niyan doon sa kanilang conjugate base? If HF is a stronger weak acid than nitrous acid, then that means in terms of the conjugate base, the one that is a weaker acid has a stronger conjugate base. So, ibig sabihin dito, alin naman ang stronger na conjugate base? Yung fluoride o yung nitrite?
Nitrite po.
Okay? So since the nitrous acid is weaker in terms of acid, its conjugate base is much stronger or stronger than fluoride. And it can be observed here in the Kb value. Okay? So yan yung information na pwede nyong tandaan. Kung stronger siya in the forward reaction as an acid, most likely it's weaker as a conjugate base. That's why may statement tayo, kapag meron kang strong acid, yung conjugate base mo ay napaka-weak. Okay? So, how do we solve weak acid ionization? So, we can identify the measure species that can affect the pH. Most likely it's just what? pH plus. In most cases, you can ignore the auto-ionization of water. You can ignore the OH minus because it's determined by H plus. Tapos, gagamit tayo ng ice equation to express the equilibrium concentration in terms of the single unknown X. So, meron tayong minus X tsaka plus X. We write the Ka in terms of the equilibrium concentration. So, we have the ice table. We have to fix them. Initial, changes, equilibrium. And then we solve for X using the approximation method, which is much easier, or we could say easier compared to the one that we did in equilibrium problem. If approximation is not valid, we have to use the quadratic formula to solve for the X exactly. And then we calculate the concentrations for all species and the pH of the solution. We can apply this also in weak base. Okay, so let's try. So calculate the pH of a 0.036 molar nitrous acid solution. Okay, given this dissociation. Now, there's also another one that you need there. The Ka value, which in this is 4.5 times 10 to the negative 4. It can be given or it is the one that is being asked. But for this type of problem, it should be given. So how do we solve this? So we can use the ice or yung tinatawag kong rice. What's the initial concentration? Anyone? Can we say that this is this? And how about H plus and NO2? What are their value?
X value po. Hindi po siya undefined po. Hindi po alam.
0. Okay? He didn't say anything there, so you can always assume it's 0. So what's the changes that we have here? Ano yung changes natin dito? Can we say this is minus X because it's in the reactant? X amount of NO2 that dissociates to form X plus, XH plus, and NO2 minus. Are we okay on that? May tanong ba kung bakit ganito yung expression? Analyze. May tanong, bakit minus X tsaka plus X? And then for the equilibrium, you just bring down everything. And then we write the expression. So this is what? Ka equals to the products over the reactant. And then we replace it with the value 4.5 times 10 to the negative 4. And then this is X, and then this is X, and then this is 0.036 minus X. Analyze. Kukunin nila ako. Na kasi boses ko eh. Question so far? Huwag mahiyang magtanong. Yes.
Doon po sa change po, constant po ba yun na kapag po sa reactant, negative po yung expression, tapos sa product po, positive po? Doon po
Yes.
sa minus X.
Kapag reactant minus, kapag product plus. That's
Hindi.
constant. And pwede ka magdagay ng ano man tawag dito, coefficient dito in front or stoichiometry depending dito. But it's just happen na lahat sila 1.
So bali po kapag may molar mass po, may coefficient po.
Kapag let's say 2 dito, 2 dito, 2. So minus 2x tapos plus 2x plus 2x. Kung ano yung nasa harap dito.
Okay po, thank you po.
Now, ano yung advantage dito compared doon sa equilibrium problem? We can always make an approximation. We can always say that this is just what? That the x value is so small that it will not affect the initial concentration. Paano? Let's say Donald Trump, bilyonaryo, nawala ng piso, bilyonaryo pa rin. So the same thing here, but there's a limit on that. Some books said if it's more than 5%, then you cannot do this approximation. But if it's less than 5%, you're good. Okay? So if we're going to make that assumption, so magkakaroon tayo ng 4.5 times 10 to the negative 4 times 0.036. And on this side is an x squared. So to get an x, we just get the square root. And that's equals to what? Square root of 162 times 10 to the negative 5, which is equals to 4.0 times 10 to the negative 3. Did you follow? Did you copy that?
Sir, yung sa 0.036 minus x, bakit nawala po siya nung parang nag-transpose po? Yung negative x pa nawala.
Kasi nga, nag-assume tayo na yung x ay masyadong maliit para maka-apekto doon sa 0.036. Yan yung advantage nito kaysa doon sa equilibrium problem.
So, pag in-assume po yung x po ay mas less than po doon sa given na sa yung 0.036, parang kinakancel out na po.
Oo. So, gagamitin lang natin yung initial concentration. But we have to check that. Okay? So, what do we have here? 4.0 times 10 to the negative 3x. That is also your H plus. So, you can get the pH, negative log of 4.0 times 10 to the negative 3, and that is equals to what? Ano kuha nyo?
2.40.
Now, the next thing that we're going to do is, let's see, kasi kailangan ang dissociation niya less than 5%. So we get this value and divide it with the initial concentration and then multiply it with 100. What do you get? You get 11%. So, ibig sabihin yung approximation mo hindi valid. And when that happens, what do you need to do?
Uulit po, sir.
You need to do the quadratic formula. So from this one, what will happen? You're going to multiply this with this. And then gagawin mo, this will become x squared minus 4.5 times 10 to the negative 4x. And then plus 1.62 times 10 to the negative 5. So x squared minus 4.5 times 10 to the negative 4 x plus 1.62 times 10 to the negative 5. And then you use the quadratic formula to find x. So I leave that to you. So usually dalawa yung x value na makukuha mo dyan. Okay, if you do the quadratic formula. So you can end up getting a value that is equals to 3.8 times 10 to the negative 3 or negative 4.3 times 10 to the negative 3. So alin yung tama dyan? What do you get? I think this is more practical because there's no such thing as a negative value for a concentration. Does make sense? Now look that value compared to the one that we get when we didn't do or when we did the approximation. So gaano siya what we call the laki yung difference if we get the pH of that. What do you get if you use that value to get the pH? Anyone?
2.42. 42.
242. So see how far it is from 2.40. Medyo malapit pa rin sila. Yep, question.
Sir,
Yep.
di ba po nakuha natin 11%? Ano po yung pong percentage po para po hindi mag-proceed sa quadratic formula?
5%.
Thank you po.
Yun yung 5% rule na sinasabi ng ibang libro. The other rule that they have is initial concentration divided by K. That should be 1,000. And I think this number divided by this is less than 1,000. So that's another way to say pwede kang gumamit ng approximation. So pareho siyang bagsak. Bagsak siya sa 5% rule, tapos mas less than siya sa 1,000 kung kinuha mo yung ratio ng initial concentration doon sa Ka value. Okay? Now, we do the same thing with the base. The only difference is sa acid, H+. Sa base, OH minus. So if we have the OH minus, dyan natin madi-differentiate alin yung Ka at alin yung Kb. Okay? So, Kb is just the base ionization constant. And kagaya ng Ka, the higher the Kb, the stronger is the weak base. So pareho lang yan sa weak acid. Ang pagkakaiba lang, hydroxide ang sa base compare sa H+ doon sa acid. So what you're getting here is from the POH and then go to the pH. And these are just some of the common weak bases. And I think the example that we have is ammonia. Like this. And again, you have to put there the Kb, which is 1.8 times 10 to the negative 5. So, kagaya ng example, ilagay natin NH3 reacting in water, producing NH4 plus and ammonia. No, not ammonia, OH minus. So that's the reaction. So ano yung initial concentration dito? Anyone?
Yung 0.04.
Ito 0. Ito wala to kasi liquid yan eh. So hindi siya nagpa-participate. So ano yung changes? Ano ilalagay ko dito?
Minus X.
Okay. And then plus X dito. Equilibrium is just bring down everything. Then I put the Kb. I write all the reactants here. I write all the products on top over the reactants and then replace it with the value that's given. Now, can we make the assumption? I can use the 0.40 divided by 1.8 times 10, and I think that's more than 1,000. Right? So I can make this like this. Cross multiplication. And then since I need to get the square root, 1.8 exponent negative 5 times 0.40. So ano yung x? Okay.
2.68 times 10 raised to the negative 3.
2.7 times 10 to the negative 3. just follow. I have two significant figures here. So I have to put this into two significant figures around it. So ano yung X dito? Yan yung hydroxide mo. So since hydroxide ang meron ka, you have to use POH, right? So negative log 2.7 times 10 to the negative 3. So that is equals to ano nakukuha nyo?
Two 2.57. 2.6.
So I could put there 2.57. But am I done? Tapos na ba yung problem? Is the problem done? Hindi pa, di ba? Kasi POH yan eh, and hinahanap pH eh. So it's just 14 minus 2.57 giving you 11.43. Analyze.
Sir, yung 0.40 over 1.8 times 10 raised to negative 5, applicable din po yan sa Ka.
Yeah. It's initial concentration divided by Ka or initial concentration divided by Kb. Kapag more than 1,000 yung ratio na yun, ibig sabihin you can make the approximation of dropping the X. So, gamitin mo na lang yung initial concentration doon. It's in some books. That's a newer one compared doon sa 5% rule. So question, so ano yung guide niyo? Yung pH value, kapag less than 7, ibig sabihin acidic siya. Kapag more than 7, ibig sabihin basic siya. So kaya ba? Bago tayo pumunta sa buffer. Whenever we have this so-called buffer solution, it's a solution that maintains the pH value. Okay? Our stomach is made up of what? Anyone? Ano yung acid na sa ating tiyan?
Hydrochloric acid.
Okay, hydrochloric acid. Pero bakit hindi nasusunog yung tiyan natin? Because we have a buffer system. Now the question is, what's the buffer system in our body? Anyone? Alam niyo ba kung ano yung buffer system sa ating katawan? So the buffer system in our body is anyone? Phosphate buffer. Okay? Now, When can you have a buffer system or a buffer solution? You can only have it if you have a mixture of a weak acid and its conjugate base in the form of salt, or a weak base and its conjugate acid in the form of salt. So iyan yung requirements ng buffer. So kapag may strong acid ka na, kung na-memorize mo na yung strong acid, strong base list natin, right away you can predict if it's an acid or a base. Okay? So both of them must be present. Now, a buffer solution has the ability to resist changes in pH upon addition of small amounts of either acid or base. Now, you may ask yourself, why weak acid, weak base, and its conjugate salt? Well, is that something to do maybe on the mechanism? Because what does it do? When you add an acid, the basic component react on it. When you add the base, the acidic component will react with it. So for instance, acetic acid and sodium acetate. How does it act? What are the species in this given system? So you have this one, which is the acid component, and this one. So anong ibig sabihin nito? Kapag nag-add ka ng acid, mag-a-act ito. Kapag nag-add ka ng base, mag-a-act doon yung acid. Example, if you're going to add a strong acid, so you have H+. So ano magre-react dito? Yung acetic acid or yung acetate? Anyone?
Yung acetate.
Okay? So ang magre-react yan ay yung acetate. Yun yung base component. And when they react, they will just form the acidic component. So walang nababago. Okay? Yung H plus na nalagyan nawala. Because yung H plus ang magpapabago sa pH. But it was neutralized by the basic component. Now, if the base is added, which is in the form of hydroxide, alin yung magre-react yan? Magre-react yan yung acidic component. At ang magpo-form ay yung acetate at tubig. So if you're going to look at the composition of the base, both components act either as a reactant or either as a reactant and a product or as a product and a reactant. So na-maintain nila yung pH. But they have a limit, yung tinatawag na buffering capacity. So sometimes the acids and the base that's added can overrun the buffer system. Now, let's try to work this one. So alin dito yung buffer system? I want you to work on it. And then maybe after a minute, let me know if each of them can be a buffer or not.
Yung letter B po, buffer.
Yung letter B, buffer. Remember our definition of a buffer. So a buffer should have what? a weak acid and
So,
so let's go one by one. Letter A, is this weak acid, weak base, strong acid, strong base? Hmm? I gave you the list earlier. Kasama ba yan sa listahan ng strong acid or strong base? What acid is this? That's your phosphoric acid. And it is weak. So if it is an acid, so that means its conjugate base is what? H2O4 minus plus an K plus. So that makes it a buffer. Analyze. Question? Huwag mahiya. So convince lahat na buffer yung number 1? Hello?
Sir,
So everyone convinced that this is a buffer?
sir,
Yep.
pwede po bang pakiulit po ng explanation po?
Phosphoric acid is a weak acid. And the conjugate base of phosphoric acid is H2PO4 minus, which fits here. That's why this makes it a buffer. Ito yung definition natin ng buffer. The weak acid and the salt of the weak acid. Salt ito ng weak acid. You may ask, why do I know it's a salt? Because it has a positive and a negative charge, this one. Question? Now, letter B, is this a buffer? You go here. This is a buffer if this is a weak acid, but is this a weak acid? I gave you a list when we are talking about strong acid and strong base. Alin yung strong acid, alin yung strong base. Pag wala siya sa listahan, weak. Pag nasa listahan siya, strong acid siya or strong base. Is HClO4 a weak acid or a strong acid? Anyone?
Strong po.
Okay, it's a strong one. So that means it's not a buffer. This is a salt of this one, but this is a strong acid. Okay? Kasi sabihin ko sa inyo, 100%, there's a question like this, which of the following can be considered as a buffer? Or which of the following cannot be considered as a buffer? The last one, pyridine. Is it a weak base or a strong base? Why did I say it's a base? Because the Kb is given. So when you have a Kb, most likely it's a base. If you have a Ka, most likely it's an acid. So the question, is it a weak acid? Is it a weak base or a strong base? Ano sabi ko sa inyo kanina? If the Ka is given, most likely it's a weak acid. If a Kb is given, you can also say most likely it is a weak base. So the next thing that you're going to do, okay, you identify that it's a weak base. Now, does it has its salt? So ano yung salt niya? So C5H5N. So if this is a weak base, so that means its conjugate acid is this one, right? And you have this one. Because the class before you told me that this cannot be a weak acid, a weak base, because you have an HCl. But is this really HCl? Is hydrochloric acid really there? So as you could see, that's a salt that you formed there. And HCl can only be HCl if it's on its own. But with this one, you cannot say HCl is there because HCl is part of the whole salt. So you have a weak base and its conjugate salt, then this is a buffer. So makakakuha kayong tama sa tanong na ganito. So the last part that we have here for today is solubility equilibrium. And then finish na lang natin next week yung metal ion thing. So in the solubility equilibrium, what we're looking for? We're looking at materials that has limited solubility. Okay? Like silver chloride. So what's the problem with the silver chloride, let's say with NaCl? So NaCl are readily soluble. The amount of the solubility is grams per liter. Compared with silver chloride, usually it's just microgram to milligram per liter. So since the amount that can dissolve in water is so small, so you could say you have a system in equilibrium. That's why you have this one compared to this. Now, you can express a new low mass of action there. So how are you going to write the expression for this? So you have KSP equals to silver ion plus chloride ion. Again, you don't include the solid. So you have here the KSP, which is just the solubility product constant. And the way you write the KSP is the same as what you learn in your equilibrium. So if you have this, you don't include this one, you just write this. So you can have the solubility product expression like this one. If you have this one, you can write it this way. Okay? Now, you may ask yourself, so what does this mean? Why is it in the KSP you only write what we call the ion products? because you always have a solid substance as your reactant. So the expression here in terms of KSP is just in terms of the amount of ion that form. Now, you can relate this ion product here like what you learned in your equilibrium as Q. So what does this mean? So depending on the ions that you have are present here and the ions that's present here, if you multiply them, you can compare it with the KSP. And it can tell you what will happen. So in addition to that, this one, the expression that you have. So what does this mean? If the ion product or Q that you have is less than the KSP, so most likely you have unsaturated solution and you don't have any solid in your solution. If your Q is equal to the KSP, you have a saturated solution. But if your Q is greater than KSP, you have a supersaturated solution and you will form a precipitate. Okay? Now, what does this KSP tells us? How is it related to Ka and Kb that we have discussed? KSP also convey us information with regards to the solubility of a given compound. And if we're given the same type of compound, we can compare right away by using the KSP, which one is soluble, let's say, between two materials. Now, ano yung ibig sabihin ng same material? So let's say, if you have a silver ion and you have like this one, so you can compare it if they have the same type. But if you have it like this, then it's another story. So what does this mean? So what if I ask you, among silver bromide, silver chloride, silver iodide, which is the most insoluble and which is the most soluble? Anyone? Ano man ibig sabihin ng KSP? Kapag mas mataas daw yung value ng KSP, mas soluble siya. Pag mas mababa yung value ng KSP, mas insoluble siya. So if I give you silver bromide, silver chloride, silver iodide, which is the most soluble and which is the most insoluble? Come on. Pwede niyo i-type sa chat. Ganyan yung mga simpleng tanong na hindi mo kailangan i-calculate. Na hindi mo pwedeng sabihin, huhulaan mo. Okay? So, which is the most soluble and which is the most insoluble? So, you look at the KSP value. So, yung pinakamataas, yun yung soluble, like silver chloride, 10 to the negative 10. So, yung pinakamababa, gaya ng iodide, yun yung insoluble. So, yan yung pwede mong gamitin yung value of KSP as is. But if you're going to compare them, let's say with silver carbonate, can you predict it right away? By just using the KSP? If you are asked which is more soluble, silver carbonate or silver bromide? The answer is you're not sure. Even though the KSP of silver carbonate is higher than silver bromide, you're still not sure if it's indeed soluble. Okay? Or silver carbonate is more soluble than bromide. Why? because look at the form that they have. So you need additional calculation. You need to determine what is the solubility of each of them. Now, there are two types of calculation. This is the last one that we're going to do in a calculation, and then we're done. So, how do you think they end up getting the values here? Paano kaya nila nakuha yan? Did they get it out of nowhere? Usually what they do is, each material, they determine the solubility, which is the grams per liter, and then they determine the moles per liter. So how do they go from here going here? Anyone? How do you go from solubility to molar solubility? Anyone? What do you do? Hello? Gutom na ba kayo? So you use what? The molar mass. And once you have the molarity here, you can get the concentration of the cations and anions, and then you get the KSP. Or you're given the KSP, that's the way you're going to compare which one is more soluble between these two. You get the concentration of the cations and the anions, and then the molar solubility, and then the solubility of compound. But what we're going to do for today is just the first one. So the solubility of calcium sulfate is found to be 0.67 grams per liter. Calculate the KSP. So which one we're going to do here? The first one or the second one? Anyone?
Yung una po.
Yung una. Okay? So you have what? 0.67 grams per liter. And what do we do? What do we need?
Hanapin po yung molar mass ng calcium sulfate.
So 1 mole of calcium sulfate, that is equals to 136.2 grams of calcium sulfate, and that is equals to what? 0.67 divided by 136.2. You have what? 4.9 times 10 to the negative 3 moles of calcium sulfate per liter. So the next thing that we do, we're done here. Concentration of cations and anions. So paano gagawin natin dyan? So we can put calcium sulfate, dissociate to give you calcium 2 plus and sulfate ion. So that means if I have a 4.9 times 10 negative 3 here, molar, I also have 4.9 times 10 to the negative 3 molar here. The same thing here. So if I have the KSP, that is equals to Ca2 plus times SO4 2 minus. So I get the value there, which are just the same. So what do I have? Ano makukuha natin sa number na to?
2.4 times 10 raised to negative
2.4 times 10 to the
5.
So yan yung KSP. Let's see how. Is it here? Wala. Walang calcium sulfate eh. So that's how you get the KSP. Now, nakita niyo ba yung link ng video ng mga recordings natin?
Yes po.
Okay?
Yes po, sir.
Okay.
Pero
Now,
hindi ko nabuksan.
if you want more example, yung channel na yun, may mga example siya doon galing doon sa ibang klase ko. Okay? So all you need to do, if you ever went to that YouTube content, so this is the one. So you could see there, you have a UPLB Chem 18U. Kayo yung B. Okay? But I also have here Gen Chem. So if you want more example, okay, to supplement, kasi ang problema sa atin, we don't have enough time. But I was instructed that I just need to use the course pack. Hindi na ako magdi-deviate doon. But if you want more example, there are some what we call thing there. So itong coverage natin is 15, 16, 17. Yung chapters dyan na nakasulat. And the problems that you have there is different from the one that we had doing at this time. Okay? So I would suggest read the course pack, and then we might, I might have this like consultation hours Monday, 10 to 12. So if you have any question, you need help, I think I'm going to email the Zoom links after we meet on Thursday. Because we still meet on Thursday, but I would suggest you start doing the course pack that is in the Moodle. Okay? And the way that we're going to do next time, hindi na ako lagi yung magbibigay ng ano, it's mostly, I'll ask question from you, which part of the course pack or the module that you don't understand. Sinabihan kasi ako na wag ka mag-lecture. You're supposed to read the course material. And if ever you have question, that's the time I'm going to help you. Okay? So question.